Okay. All right, guys, here we go. We are going to be solving quadratic equations by factoring. So again, we've been doing all of this factoring so that we can use it to solve quadratic equations. Remember when we were graphing the parabolas and we were not able to find the x-intercepts because we couldn't set an equation equal to 0 and solve? Now we're finally going to be able to do that. We're going to be able to finally solve the quadratic equation using factoring, all right? So just remember, a quadratic equation, it's a degree 2 equation, which means the highest exponent on a variable is 2. So it's all of these x squared equations, all right? Standard form looks like y equals ax squared plus bx plus c. So we're going to be letting y equal 0, and we're going to be solving for x. So we're going to be finding the x-intercepts because they have an x when their y value is 0. All right? Just to give you a little bit of a hint, the degree of an equation is always equal to the number of solutions or answers it has. So a degree 2 equation, guys, it's going to have 2 answers. So when you solve a quadratic equation, you should get 2 answers to that. Back in chapter 1 and 2, when we were solving linear degree 1 equations, we got 1 answer. So that's always a good kind of cheat sheet. Whatever the degree of the equation is, that's how many answers you should get when you solve its equation. All right, well, guys, there's lots of different ways to solve a quadratic equation. The first way, the number 1 way to solve a quadratic equation is by factoring. That should be your go-to way to solve a quadratic in the future. However, you're going to see not all quadratic equations factor to these beautiful whole number factors. So factoring isn't always going to work, so we do have to have another method to rely on. So if we can't solve the quadratic equation by factoring, in the future, I'm going to teach you to use the quadratic formula, or I'm going to teach you to use square roots. But square roots only work on special cases. And then there's a 4th way to solve a quadratic equation. It's called completing the square. But guys, I don't teach you that. You don't learn that until pre-calc, all right? So you're going to learn how to solve a quadratic by factoring today. Then we're going to use the quadratic formula and square roots as other ways to solve quadratics, all right? Okay. And Gianna, if you don't get all this, I can print them out for next week if you don't get everything written down, okay? All right, so guys, when we solve a quadratic equation by factoring, we're going to use the zero product property. This is what factoring is going to do. By breaking it up into pieces that multiply, it's going to allow us to use the zero product property. And the zero product property says this. And I'm going to pause and let you guys think about this. If I told you 8 times something equals 0, does anybody know what that something has to be? What does that missing piece have to be in order for 8 times it to equal 0? Anybody know? It's got to be 0. The missing piece has to be 0. In math, the only way 2 pieces can multiply to 0 is if somebody was 0. So you know this missing piece had to be 0. So we're going to use that knowledge when we're solving an equation by factoring. All right? What if I told you something times negative 24 ended up equaling 0? Guess who that missing piece had to be? It had to be 0. Because the only way 2 pieces can multiply to 0 is, are you from Mr. Muller?
Yeah.
Sit anywhere in that next, bud, and just make yourself comfy. The only way 2 pieces can multiply to 0 is if somebody is 0. All right? And then what if this? If x, some unknown value, times something equals 0, well, guess what? The missing piece could have been 0, so that 0 times some number equals 0. Or, guys, x could have been 0, and then this could have been any number we wanted. But the point is, somebody had to be 0. And the same thing over here. If this times 2 ended up equaling 0, well then guess what this had to be? This had to be 0. X plus 3 had to equal 0, and now we know x had to be negative 3 in order to make that statement true. And that's exactly how we're going to solve equations by factoring. We're going to use the zero product property. The fact that when you multiply 2 things together, if they equal 0, somebody had to be 0. So in that we say if A times B equals 0, then A or B must have been 0. Tessie, can you turn your camera on? It was on before. I'm gonna lose my mind, yeah. All right, here we go. That's a no, I'm assuming. So now, if we look at it, if you want to solve a quadratic equation by factoring, I gave you a list of steps. The first thing you want to do is get everything on one side set equal to 0, so we can use the zero product property. Then we're going to factor it. Then we're going to set each factor equal to 0 and solve. And just remember, the number of answers should match the degree of the equation. So if we're solving a degree 2 equation, we should be getting 2 answers. All right, here we go. Let's do it. All right, so we're going to solve this quadratic equation by factoring. So the first thing we would do is get everything on one side set equal to 0. We want to be able to use the zero product property. So we want it to equal 0. So that part is done for us. Now we're going to factor this. What do we always look for first? A GCF. So what does a 2x squared and a 10x have in common? A 2 and an x. All right, so what's left? 2x times what gets me back to 2x squared? X. 2x times what gets me back to negative 10x? Minus 5. Now, what do we normally do after we take out a GCF? We bring the GCF down and we try to factor this again. But guys, this isn't a quadratic expression. This is a linear expression, a degree 1 expression, and that should not factor again. So technically, you are done factoring. So look what you've done. By factoring this, by breaking it up into pieces that multiply, now you're saying that this times this has to equal 0. Guys, the only way that this times this could equal 0 is if somebody is 0. But is this supposed to be 0 or is this supposed to be 0? We don't know, so we find out what makes them both equal 0. So what's it going to take for 2x to become our 0? Solve this little teeny equation, and you find out that x has to be 0. So that's one of your 2 answers to this quadratic expression. All right, but what if this one wasn't supposed to be 0? What if this ended up being some number and he had to be our 0, so that a number times 0 equals 0? So then what's it going to take to make this factor, x minus 5, to become our 0? So now you're left with another teeny tiny equation to solve. So now I'm going to add 5 to both sides. And now we find out that x has to be 5. So those are your 2 answers to your quadratic degree 2 equation. Now guys, watch. If you plug them back in, plug 0 in. 2 times 0 squared is 0. Negative 10 times 0 is 0. 0 minus 0 equals 0. It makes the original equation true. If x is 5, 5 squared is 25. 25 times 2 is 50. Negative 10 times 5 is negative 50. 50 minus 50 equals 0. Both of these numbers make the equation true. Hey, Floor, come on in. Floor, I couldn't print them out because the printer's down. All you need is a piece of paper, okay? All right, also, guys, if x equals 0, watch this. 2 times 0 is 0, times 0 minus 5 is negative 5. 0 times negative 5 equals 0. It makes the equation true. If x is 5, 2 times 5 is 10, times 5 minus 5 is 0, 10 times 0 is 0. It's 0. They both make the equation true. Guys, and also, by setting this equation equal to 0 and solving, you're solving for x when y is 0. You have also just found the x-intercepts of this parabola's graph. You now know that this parabola will cross the x-axis when x is 0 and when x is 5. And since a was positive, we know the parabola is opening up, and now you have a visual as to what this parabola will look like. And his vertex will be right there in the middle. But you are finding the x-intercepts of his graph, the zeros, the roots, the solutions, whatever you want to call them. All right? All right, perfect. Let's keep going. Let's do it again. All right, give me a thumbs up if you remember doing this. You did it in Algebra 1. Give me a thumbs up if you remember doing this. Are we all right? Okay. All right. When we are factoring, guys, I'm not going to spend a lot of time showing you that. You should know exactly where I'm getting these factors from. We spent 7 days on the factoring, okay? All right, let's look here. If I want to solve this quadratic degree 2 equation for x, first, we need everything to be on one side set equal to 0. So I can move this to that side or this to that side. It doesn't matter. I like the number in front of x squared to be positive when I go to factor it. So since the number in front of x squared is positive, I'm going to leave this stuff here and move the 2x to the same side. All right, now, when I move it over, I don't have any like terms, but I do want them in a certain order when I go to factor. So let's write them in the correct order. 2x squared should be first, negative 2x should be in the middle, and negative 40 should be at the end, and now it equals 0. All right. So now that we have everything on one side set equal to 0, and we want it equal to 0, so we're going to be able to apply that zero product property. All right, now we factor. What do we always look for first? We always look for a GCF. Thank you. Right? Take the GCF out. We'll make this easier to factor. So what do they have in common? A 2. Let's take it out. So what's left if I factor a 2 out? 2 times what gets me back? X squared. 2 times what gets me back? Negative x. And 2 times what gets me back? A negative 20. Okay? Now, I'm going to bring my GCF down, and I'm going to try to factor this quadratic expression one more time. All right, we know whatever we put in the first two spots has to multiply to x squared. Who do we always use for that? X and x. Beautiful. And then I know whatever number I put here and whatever number I put here, they have to multiply to negative 20, and my rainbows have to add up to that negative 1x in the middle. So again, maybe you have to sit here and guess and check that a little bit, but a lot of you, your factoring quizzes were beautiful, so I know you know how to factor. We're going to need a -5 and a +4. Right? That will multiply to my negative 20, and my rainbows get me that negative 1x in the middle. All right, so guys, look what you said now. By breaking this up into pieces that multiply, by factoring this, you're now saying that this times this has to equal 0. The only way that these could multiply to equal 0 is if somebody was 0. But is this supposed to be 0 or is that supposed to be 0? It could be either one. So we have to find out what makes it all equal 0. So take your factors and set them equal to 0. All right, so what's it going to take for 2 to equal 0? Well, guys, 2 has no variable to solve for, and 2 doesn't equal 0. So we're not going to get an answer from him, but I don't want you guys forgetting about your GCF, because if the GCF does have a variable, we will get an answer from him. All right, what about this? What if this factor was supposed to be our 0? So what's it going to take to make x minus 5 become our 0? What does x need to be? Add 5, and x needs to be 5. So that's one answer to our degree 2 quadratic equation. All right, what if it was this factor though? So take this factor and find out what x needs to be in order to make him our 0. So I'm going to -4, and I find out that x equals -4. So those are my two answers to my quadratic degree 2 equation. It also is, guys, those are the x-intercepts. These are the points where his parabola would cross over the x-axis. He would definitely have an x-intercept at 5 and an x-intercept at -4, and since A was positive, it would have opened up. So you already have a visual as to what his parabola would look like. These are his x-intercepts. All right, give me thumbs up if you guys are okay. All right, how do you guys feel? Good? Excellent? How do you feel? Yeah. Better than history, right? That's right. Yeah, it does. All right, let's keep going. Try and get a couple more done before we get kicked out of here. All right, so guys, look at this one. What's the first thing you want to do? Where do you want everything to be? On one side, set equal to 0. Beautiful, John. So you have two options. I can move this over here or this on this side. I like the number in front of x squared to be positive. So I base all of my movement on that. So since the number in front of x squared is negative, I'm going to add him to this side, so now he'll be positive. All right? Now I don't have anything on that side, which is good. I want it equal to 0. On this side, I don't have any like terms. So I want to make sure I write everything in the correct order. First, you want our x squared, so our 9x squared. Then we want our x's, so negative 12x, and then we want our number, so plus 4. All right, so we have everything on one side set equal to 0. So now we want to factor it. We want to break it up into pieces that multiply. What do you always look for first? A GCF, but guys, they don't have one. A 9, a 12x, and a 4 do not have anything in common. So that means we're going to factor it just the way it looks. So again, you're going to have to sit here and play around with your rainbows and find the numbers that work. But we know whenever we put in the first two spots, has to multiply to a 9x squared, right? So that leaves us with the options of 9x and 1x, or 3x and 3x. Just because I've already showed you how to factor, I'll spoil it. I'll tell you, it is 3x and 3x. That's what we're going to need to get our 9x squared here and to make our rainbows work to get that negative 12x in the middle. All right, we know whatever numbers we put here and here have to multiply to that positive 4, right? And then we'll work those rainbows to get our negative 12x's. So guys, that means I can put 4 and 1 or 2 and 2. Spoiler, we're going to need a 2 and a 2 to make this work. All right, and now what signs do we need to multiply to that positive and then add up to that negative 12x in the middle? Negative, negative. So if you notice, they actually factor to the exact same factor. That's fine, that's fine. All right, so now look what we said. We're saying that this times this has to equal 0. The only way that could happen is if somebody was 0. But who? Did he have to equal 0? Or did this one have to equal 0? They both could have been 0. So we set them both equal to 0 and we solve. So what's it going to take to make 3x minus 2 become our 0, equal 0? So all you got to do is solve this teeny little guy. We're going to do what? Add 2. And divide by 3. And you find out that x ends up equaling 2/3. 2/3 is one of your two answers to this degree 2 equation. Now, when you go to set the other factor equal to 0, you should be like, wait a minute, it's the same guy, it's the same factor. So when you set him equal to 0, the same thing happens, and you end up with another answer of x equals 2/3. So you do get two answers, it just happens to be the same answer twice. We call that a double root. Something special happens at his graph, but either way, if you're a person like me and you want to see two answers, those are your two answers. However, you only really have to list it once as an answer because it's the same number 2 times. So guys, that just means that this parabola only touches the x-axis one time at an x-intercept of 2/3. And we know it opened up because A was positive. So he's one of those parabolas that did this, that only had one x-intercept. It was right on the x-axis. All right? All right, give me a thumbs up if you're still feeling good. How do you guys feel? Good? Good? Everybody? All right, we're going to try and do one more before the bell cuts us off. What time are we here to? 41? 40? Okay. We got time. All right, one more. Whoa! What happened? This one's huge. Remember, our first main goal is to recognize this is a quadratic equation, right? In order to solve it, you got to get everything on one side set equal to 0. So guys, it doesn't matter which way you move things. I try to base it off of the x squared. I like the number in front of x squared to stay positive if I can help it. So if I move my 4x squareds to this side, I'd have to minus them, and now I'd have a negative number in front. And I'm not loving that idea. And then if I move 2x squareds to this side, I'd minus them, and they'd stay positive. So I'm going to choose to do that. I like the number in front of x squared to be positive. So let's do that. Everything's going to the left. So we're going to minus 2x squareds, minus 2x squareds, because now I have like terms that I can actually combine them with. All right, I'm going to have to add my 5x's. Then I'm going to add them over here because, again, I have like terms this time. And then I'm going to have to minus my 8 because I have like terms. All right, and then when I do it, cancel, cancel, cancel. I am equal to 0, which is what I want. I want to be able to use that zero product property. All right, now I'm going to get what? 2x squared. My x's actually end up canceling out. I don't have any more x's in this problem. And then negative 10 minus 8 more, minus 18. So we're left with this teeny tiny quadratic equation. We are being asked to solve this by factoring, although in the future, he'll fall under a category where you could use square roots, and I'll show you that in the future. But right now, we're being asked to solve by factoring. So what do we always look for first? A GCF. What does a 2x squared and an 18 have in common? A 2. Take it out. Show me what's left. And we go. 2 times what gets us back to a 2x squared? X squared. 2 times what gets us back to a negative 18? A minus 9. So now what do we do after we take a GCF out? We look to factor again, right? This is a quadratic expression, so it could factor again. So bring the 2 down. Let's see if we can break that guy up one more time. So if you look at it, he shouldn't look normal. It doesn't look like your normal ax squared plus bx plus c expression. He looks so tiny, right? So ask yourself, could this be the difference of 2 squares? Is this a square subtract a square? Yeah, and we love them because they factor so nicely, right? They always factor to those matching factors, but with opposite signs. So what times what multiplies to x squared? That matches. X. We know the numbers we put here have to multiply to that negative 9, and they have to match. So who are we going to use? 3 and 3. And now what signs do we need to multiply to that negative 9? And then our rainbows will add up to those 0 x's that we have in the middle. A plus and a minus. All right, so guys, look at it. Look at what this problem is saying now. Now that we've broken it up into pieces that multiply, now that we've factored it, it's saying that this times this has to equal 0. The only way these could ever multiply to equal 0 is if somebody was 0. But who? It could be any one of them. So we have to find out what's it going to take to make each factor equal our 0. So if you take 2 and set them equal to 0, he does not have a variable to solve for, so we're not going to get an answer from that, nor is it even a true statement. So we're going to forget him. All right, but what if x plus 3 had to be 0? What's it going to take to make x plus 3 become our 0? Minus 3, and x would have to be negative 3. So there's one of our 2 answers to this degree 2 equation. And then we come over here, but what if this guy was supposed to be our 0? What's it going to take for x minus 3 to equal 0? Add 3, and x would have to be 3. So 3 is our second answer. So our 2 answers are negative 3 and positive 3. And it also means that this parabola would cross the x-axis at a positive 3 and a negative 3. These are his x-intercepts, his roots, his zeros. And since A was positive, we knew it would open up. And now you have a visual as to what his parabola could look like. All right? How's that feel? You seem really good. You're good? How do you feel? Good? All right. Everybody at home, give me a thumbs up. How are we doing over there? Excellent. Like I said, hopefully the factoring isn't the hard part anymore. We spent 7 days on that. We should know how to factor. Now all you have to do is that one extra step. Take your factors, set them equal to 0, and solve. All right? All right, guys, you are going to have a homework assignment on Delta Math. It's 8 questions on solving by factoring. It's due tomorrow night at 11:45. And then, guys, remember, we have no school Friday or Monday, so tomorrow's the last day. All right? Let me double check the attendance. If anybody has any questions, please stay on the meet. Otherwise, you will be free.